This is video number 2 for section 8.5. And what I'm going to do is lay out the procedure for using the partial fraction method to integrate. So the first thing you should do, by the way, I should clarify that this process is going to be aimed at linear factors in the denominator only. So in our previous example, our factors of our denominator were both x to the first power. If one of the powers was raised, if one of the factors was raised to the second power, or if within the factor itself we had something quadratic or cubic, then we have to make some adjustments to our work. So this is, if we have linear factors, the most simplified form of partial fractions, this is what we should do. Well, we should start off by factoring out the denominator. Once we've factored out the denominator, what we're going to do is we're going to write each factor separately in its own fraction. So I'll have one fraction, capital A over the first factor, plus capital B over the second factor, plus capital C over the third factor, and then however many additional factors I need. Okay, so it just depends on how many factors we create in our denominator. You'll want to remember that when you do that, don't just write it as a sum of fractions, but make sure that it is in fact an equation, where you're setting it equal to your original fraction, in other words, your original numerator, all over your factored denominator. Okay, so keeping it as an equation, partial fractions all added together equals the original. I'm going to put a little note here. If you have non-linear factors, or if you have any repeated linear factors, this particular step will change slightly, and I will address that in my next video. Okay. So if you have any nonlinear factors, such as x squared plus a, or if you have any repeated linear factors, such as x minus a to the n power, then we'll do something a little different there. Alright, step number 3 is that you're going to be able to cancel those denominators out. Since it's an equation, we've made sure that it's an equation, where the denominator on one side is exactly the same as the denominator on the other. We can cancel those out and focus on the numerators. So once the denominators are gone, you're going to look at your numerators and you're going to distribute. Okay, distribute all the way through to eliminate all the parentheses. Once you've distributed, what you're going to do is you're going to gather your like terms. So you're going to gather your x squared term, your x terms, and your constant terms. And you're going to factor out the x squared, x, and the constant. So that what you're going to have is an x squared times an a plus b plus c, whatever you have, plus an x times some form of a, b, something, and then some constants, a minus c or plus c or whatever you have. It's going to vary depending on the problem. But you're going to have factored out your x squareds so that on the inside of the parentheses all you have are a's, b's, c's. Factor out your x, again in the parentheses only a's, b's, c's. And then there isn't really a constant to factor out, but you're going to have another term that represents constants. Okay. From here, what you're going to do is you're going to set up your system of equations. And your system of equations is going to consist of an equation representing the x squared terms, an equation representing the x terms, and then an equation representing the constant terms. So you should have at most a 3 by 3 system of equations. Sometimes you won't have an x squared term. Sometimes you may not have a constant term. But at most you'd have a 3 by 3 system. Alright, from here, obviously you solve your system. And then I'll remind you that you can use substitution, elimination, matrices, and any other technique you might have for solving systems of equations. But you're going to solve your system, and then you're going to replace your a, b, and your c values or expressions into your partial fraction decomposition. Okay, I'm going to say here see step 2. So in step 2 you should have written out those fraction decompositions with a's, b's, and c's, and now you're going to replace them with specific numerical a, b, and c values. Finally, you're going to integrate each fraction individually and then add all of your antiderivatives together for a final answer. So there's a lot of steps to this process. They are not short problems for sure. But I will end video number 2 here, and then in video number 3 I'll take a look at some more examples.